Hello friends, in the last video we have seen scalar product. Okay, we have defined scalar product. Then what happens when the angle between the two vectors is 0, when the angle between the two vectors is 90 degree, and when the angle between the two vectors is 180 degree. Those were boundary conditions kind of, but then the angle between the two vectors can be anything between 0 and 180, right? So now here when we have two vectors and we are taking the dot product or scalar product, let us see what happens there. Now before that we have seen what are I cap and j cap and k cap. Okay, these are unit vectors along x, y and z axis. Now what is the significance? Let me explain that. This is for the y axis and this is my x axis, correct? There is this point, let us say p 4 comma 3, correct? This is our origin. Okay, then what is vector p bar? Vector p bar is, I connect this with this point p here, okay, and this is my vector p bar, correct? Now this p bar, if I resolve in horizontal and vertical components, then what I do here is I draw a perpendicular here, and then this part, it is called px, and this is py, x component and y component. Now in this case, my x coordinate of point p is 4 and y coordinate is 3. So that means magnitude of px, that is equal to 4 and py is equal to 3. But then here we need to express this vector vector p bar as resultant of these two vectors. So how do we do that? So for that, what I do is to px I multiply by I cap, and to py I multiply by j cap. So this would be px I cap is the horizontal vector, and this is py j cap, correct? So here px I cap plus py j cap is equal to p bar. Okay, now then, after that, you in place of px you can put 4, and in place of py you can put 3, and then you can say that my p bar is 4 I cap plus 3 j cap, correct? So like that, every vector can be expressed in terms of x, y and j components and the unit vectors along those different directions, correct? So suppose my vector p bar here, okay, now I am defining p bar and q bar. P bar is px I cap plus py j cap plus pz k cap. Here I have defined the vector in 2 dimensions. Okay, we are not taking into account z coordinate, but then here, to make it more general, we are taking all the components along x and y and z axis. Similarly, our q bar will be equal to qx I cap plus qy j cap plus qz k cap, right? So now let us take dot product or scalar product of p bar and q bar. So I would be able to write here as p bar dot q bar is equal to px I cap plus py j cap plus pz k cap into, or dot here, qx I cap plus qy j cap plus qz k cap. Now what? We know that this scalar product is associative. Okay, so I'll multiply this vector to this entire vector, then add this vector multiplied by this and this multiplied by this. Okay, so it would be px I cap qx I cap plus qy j cap plus qz k cap plus second vector py j cap dot qx I cap plus qy j cap plus qz k cap plus this third vector right. Now let us multiply by this vector inside the bracket. Okay, so what am I going to get here? The first term that I get would be px qx I cap dot I cap plus, now listen carefully, it would be px I cap dot qy j cap. Okay, px I cap dot qy j cap plus px I cap dot qz k cap plus, now here I have py j cap, so I'll write py j cap qx I cap plus second term would be py j cap and qy j cap. Okay, so it would be py qy j cap dot j cap plus py j cap dot qz k cap. Correct. Now what? Next one is this the third bracket. Let us solve it. So it is pz k cap dot qx I cap plus pz k cap dot qy j cap plus pz qz k cap dot k cap. Now if you see here, I cap dot I cap, what is the magnitude of I cap? It is 1. It's a unit vector, so its magnitude is 1 unit. Correct. So I cap dot I cap, angle between I cap and I cap is 0. Correct. And cos of cos 0 is equal to 1. Correct. So I am going to have only px qx. Correct. So it is px qx plus, now here px I cap and qy j cap. Px I cap is along x axis, qy j cap is along y axis. So the angle between them is 90 degree and cos of 90 degree is 0. We know that I cap dot j cap is 0. So this is going to become 0. I cap dot k cap, again that is going to become 0. So I am not writing that. Okay. Py j cap qx I cap. So j cap and I cap are perpendicular to each other. So again that is 0. Py qy, yes, py qy and j cap dot j cap is equal to 1. So I am having py qy here. Then next is, again if you see this, j cap dot k cap perpendicular to each other, right? So 0. So I am not writing that. K cap I cap 0, k cap j cap 0, and pz qz into k cap dot k cap. K cap dot k cap is equal to 1. So it is pz qz. Correct. So you have simplified form of p bar dot q bar as this. So is it not simple? When you have a vector and its components along x, y and z axis, okay, then then for the scalar product, what you do is you just multiply, you take the products of x components and y components and z component, add them and you get the scalar product. So as an example here, okay, I am just erasing this. Okay, so let us have p bar is equal to 4 I cap plus 3 j cap plus k cap, and q bar is equal to 3 I cap plus j cap minus 6 k cap, let us say. Okay, now here px is 4, py is 3 and pz is 1, qx is 3, qy is 1 and qz is minus 6 here, correct. So p bar dot q bar I can very easily write down as 4 into 3 plus 3 into 1 plus 1 into minus 6, correct. So that gives me 12 plus 3 minus 6. So it is 15 minus 6 and that is 9 units, correct. So p bar dot q bar would be equal to 9 units here. Okay, you can modify this problem in terms of in some practical example, like a force. Okay, F bar is equal to, you take in which direction the force is acting, what is the magnitude of force. Okay, so depending on that, if a force is given as 4 I cap minus 3 j cap plus k cap, and the displacement which is caused, that is equal to I cap minus j cap plus 3 k cap. Okay, then work done is equal to F bar dot S bar, and that is equal to 4 plus 3, because minus 3 into minus 1 is 3. So, and then plus 1 into 3, that is 3. So that would be equal to 7 plus 3 equal to 10. So if this force is given in Newton and displacement if it is meter, then work done by this force and because of the displacement caused by this force, that would be equal to 10 joule, right. So that is how we deal with scalar product. In the next video we are going to talk about vector product of two vectors. Thank you so much.